We are on FRQ topic number 7. This is motion along a curve, parametrics, and vectors. Okay, almost always with a calculator. You can see the recent years. There was a pretty big gap when they did not have a question on the exam, but lately it's been very consistent. So my thought is that the makers of the AP exam feel that this is a very important topic. Okay, that's a good thing. My students usually do well on it as long as they know their formulas. It's very formula heavy, so you have to know your formulas. So flashcards, your formula sheet, whatever it takes, know your formulas. Okay. The position might be given to you, or you might have to find it in the problem. It can be either a point or a vector, either one. Okay. Velocity, in parametrics, velocity is always a vector, always a vector. X prime, Y prime are the coordinates of the vector, of the velocity vector. Acceleration is also always a vector. Acceleration is the second derivative of positions, and it has two coordinates. When you get to Calc 3, you'll have 3 dimensions. So there will be an x prime, y prime, and z prime coordinate for the velocity, and similarly for the acceleration vector. Okay, speed. So the things that I have marked with a star are almost always asked. Okay? The things that I mark with a triple star are always asked. There are 2 of those on your sheet. Okay, speed. Speed is the absolute value of velocity, but since velocity is a vector, it's not just the absolute value of velocity, it is the magnitude of the velocity vector. The magnitude of the velocity vector, the length of the vector. So think of the Pythagorean theorem. Okay? Square root x squared, x prime squared plus y prime squared. So speed is the magnitude of the velocity vector. Okay, x prime and y prime by themselves determine leftward movement and vertical movement. So if x prime is negative, you're moving to the particle is moving to the left. X prime positive, rightward movement. Y prime negative means downward movement. Y prime positive means upward movement. Okay. Magnitude of displacement. I haven't seen this asked on an FRQ, but it might be there. You never know. Magnitude of displacement only deals with position. No primes. No primes. It's delta x squared plus delta y squared under that square root. Okay. Total distance traveled. Always asked. It is the integral of speed, which means it's the integral of that square root with x prime squared plus y prime squared. Slope of the tangent line. Slope of the tangent line is dy dx, which is y prime of t over x prime of t, dy dt over dx dt. If you are asked for a second derivative, and I haven't seen it asked lately, but if you are, you have to take the derivative with respect to x of dy dx. But dy dx will have t's in it. So you're taking dy dx of something with t's in it. Therefore, you first take the derivative with respect to t, and then you multiply by dt dx, which is 1 over dx dt. All right? Okay. Let's take a look at a couple of examples. Excuse me. still working on a little bit of this summer cold as I make this video. Alrighty, the problem from 2016. The global average was 4.1. This was before I started teaching Calc BC at KHS. So I don't have that information. Okay. At time t, the position of a particle moving in the xy plane is given by the parametric functions x and y, where dx dt is this function, and they're not giving us dy dt, but they give us the graph of y. This is with a calculator, so I'm going to grab my calculator. I'm going to delete what's here from my previous videos, and I'm going to go ahead and put in dx dt in for y1. Not in parametrics though, just in function mode. So x squared plus sine of 3x squared. Double check it, make sure you get it in there right. I think we're good. Okay. They too tell us that at time is equal to 1, the particle is at position 5, 1. So they are telling us that x of 0 is 5 and y of 0 is 1. We already knew that y of 0 was 1 because this is the graph of y, and y of 0 is 1 over there. Okay, part A, find the position of the particle at time 3. Okay, find the position of the particle at time 3. Well, remember that the particle has an x-coordinate and a y-coordinate. I'm going to do the x-coordinate first. I know x of 0, and I know dx dt, so I'm going to use the fundamental theorem of calculus to get x of 3. So I'm going to set it up. X at time 3 minus x at time 0 is the integral 0 to 3 of x prime. Okay, so x at time 3, x at time 0 is 5. I'm moving that to the other side. And now I'm going to go to my calculator. Get out of the glare. Okay, 5. Oh, did I put that in there? Yes, I did. Never mind. Okay, 5 plus math 9, 0 to 3, y1. And that will give me the x-coordinate at time 3. Now for the y-coordinate at time 3. The y-coordinate at time 3, I don't need to do the fundamental theorem because this is the graph of y. What is the y-coordinate at time 3? At time 3, the y-coordinate is negative 1/2. So the position at time 3 is, they gave me the position as a point, so I'm going to give them back the position as a point. Just like that. Alrighty. Part B. Find the slope of the line tangent to the path of the particle at time 3. Slope. Slope is dy dx. Slope is dy dx. Okay? I should have done this. Position. Position is the x-coordinate and a y-coordinate. That's position. Slope is dy dx. So I want dy dx. And I want it at time 3. I want it at time 3. I know that that is dy dt at time 3 divided by dx dt at time 3. Okay, what is dy dt at time 3? Well, I have the graph of y. What is dy dt at time 3? Well, that is the slope of the tangent line here. So that is up 1 over 2, so that is 1/2. So dy dt is 1/2. For dx dt at time 3, all I need to do is go plug in 3 for t here, right? I could use my calculator for that, or I can just go ahead and put 3 in and safe stop. I think I'm just going to do that. So 3 squared is 9, plus sine of 3 times 9 is 27, and I'm just going to safe stop right here. Okay? So just because you have your calculator doesn't mean you have to use it. So I think I'm just going to stop right there. Part C. Find the speed of the particle at time 3. Speed. Think formulas. So speed is the square root of x prime squared plus y prime squared. That's speed. So I have the square root of x prime, and they want it at time 3. So x prime at time 3 squared plus y prime at time 3 squared. That's the speed at time 3. X prime at time 3, I can use my calculator to get, because I have a formula for x prime, right? Y prime at time 3. Y prime at time 3 was that 1/2, right? So this is going to be the square root of x prime at time 3 squared plus 1/2 squared. And I think I'll just use my calculator to get this. Okay, square root y1 squared plus 0.5 squared. 27.080. Always at least 3 values after your decimal point. Part D. Find the total distance traveled from time 0 to time 2. Total distance traveled is the integral of speed. It's the integral of speed. Okay, so I'm going to set that up. And I want it from time 0 to time 2, they say. So we'll have the integral from time 0 to time 2 of the square root of x prime of t squared plus y prime of t squared. X prime I have an equation for. Y prime I do not have an equation for. Let's go look at our graph. Remember, I want this from 0 to 2. From 0 to 2, and I'm looking at the slope of this because I want y prime, right? And I see 2 different pieces. So I'm going to have to split that integral into 2 pieces. One piece from 0 to 1 and one from 1 to 2. So I'm going to say what I'm doing here. I'm going to split this up into 0 to 1 of x prime of t, which I know the equation for, squared, plus that y prime squared. What is that y prime? Well, this y prime, the slope here is -2, down 2 over 1, so -2. Plus integral 0 to 1 square root x prime of t squared plus the next y prime squared. The next y prime for the next segment here is that slope is 0, so this is just going to be a 0 right here. Okay, now I can use my calculator to get the rest. So I've got Math 9, 0 to 1, square root y1 squared, I don't know why I put parentheses there, you really don't need them, plus negative 2 squared is just 4, I'm just going to make that a 4, plus Math 9, 1 to 2, square root y1 squared, like that. By the way, since this is just a 0, we get the square root of x prime squared. Is that just x prime? Is that just x prime? Could I simplify this to just x prime? No, you cannot. It's the absolute value of x prime. It simplifies to the absolute value of x prime. So, don't reduce that to x prime because it's not x prime. Unless x prime is always positive. And if that was the case, then yes, you could just make that an x prime, by the way. Okay, let's see how they scored this, and I don't have that sheet in front of me, so I'm going to... Okay, I'm back. Got how they scored this. Part A. Part A was 1 point for the integral. 1 point was for uses initial condition. And then 1 point was for the answer. So part A was worth 3 points. For part B, that was just worth 1 point for the answer. Part C was worth 2 points. 1 point was for the expression for speed. 1 point was for the answer. Part D. Part D was worth 3 points. 1 point was for the expression for distance. 1 point was for the two integrals, splitting it up into two integrals. And 1 point for the answer. Alrighty, so that was from 2016. It was, in my mind, even though it was a little different because of the graph, it was still pretty straightforward. Let's take a look at the one from 2021. And look at the global average. The global average was only a 2.2. That is very low, very low. This KHS average was very low for us, for this type of question. Usually these are much higher. Okay, let's take a look why it was so darn low. For time greater than 0, a particle moves in the xy plane with position xy. Velocity vector is given by this. So they are giving us x prime and y prime, but they are not stating it like that. So down here in part A, the very first thing that I'm going to do is I am going to state that x prime of t is t minus 1 times e to the t squared. Y prime of t is sine of t to the 1.25 power. Okay, so they're giving us the velocity vector. You need to say what x prime and y prime are in order to just write x prime and y prime. They're not giving you just x prime and y prime per se, verbatim. At time 0, the position of the particle is -2,5. So again, they are giving us that x at time 0 is -2, y at time 0 is 5. So I'm going to write that here because, again, they're not giving us that verbatim. Okay, part A. Find the speed of the particle. Well, I know how to find speed. It is square root of x prime squared plus y prime squared. No integral, just square root. And we want it at time 1.2. And then we're going to find the acceleration vector. And that is x double prime, y double prime. Formula heavy, you guys. Formula heavy. So, we can do this. Speed, since they're asking me to find two different things, I'm going to label them. Speed at time 1.2 is square root x prime at time 1.2 squared plus y prime at time 1.2 squared. So now I'll go to my calculator. Okay. I'm going to clear out what's there because in for y1 I'm going to put x prime making sure that we get it right, make sure it matches, and in for y2 I'm putting y prime sine of x to the 1.25. Make sure you get those in there right. I always double check. Okay, so down here I'm going to say this is, and I could do what I did before and just write in the values and write it. It would probably take me a little longer. Now, I do this sometimes too, you guys. In for y3, I'm going to put my speed formula. So square root y1 squared plus y2 squared. Now I have speed in for y3. So in my home screen, I can say y3 at time 1.2. And I can get my answer easily that way. And now that speed is stored in for y3, I can also get total distance traveled. I'm sure they're going to ask me that. I can see it right here. So I know that they're going to ask me that. Now I can use that speed function when I'm finding total distance traveled as well. Let's take a look at part B. Find the total distance traveled. Okay, total distance traveled is the integral of speed from 0 to 1.2. So for part B, integral 0 to 1.2 of the speed expression So do you see how I'm using x prime and y prime? I would not have been able to do that. I would not have been able to use that notation had I not stated what x prime and y prime were. Okay? You have to state that. Okay, now I can just go to my calculator. So I have math 9 for the integral, 0 to 1.2 of y3. That's where I have my speed function. And I give at least 3 values after the decimal point. Okay, part C. So far, I think that this was very straightforward. Very straightforward. And I will tell you that so far, part A was worth 2 points. 1 point for the speed answer, 1 point for the acceleration vector answer, which I did not find. I just realized that I never did find the acceleration vector. So I need to go and find the acceleration vector. Let me come over here, and I'm going to stick in the acceleration vector, good grief. The acceleration vector at time 1.2 is, and I need to say what I'm doing, x double prime at time 1.2, y double prime at time 1.2. Again, say what you are doing. Okay? So that's going to be math 8 of y1 at time 1.2, and then of y2 at time 1.2. So 6.2466, 0.4051. At least 3 values after the decimal point. Okay, so 1 point for speed, 1 point for the acceleration vector. Okay, I'm glad that this happened, because it's a good reminder that when you're asked to find two different things, sometimes you go ahead and do the first thing and you just forget about that second thing. So go back, look back over your problem, and make sure that you've done everything that they have asked you to do. Part B was also worth 2 points. It was 1 point for the integrand of the integral and 1 point for the answer. Okay? All right, let's take a look at part C. Because so far this was pretty straightforward. Even though I forgot the acceleration vector, it was still pretty straightforward. Part C must have been what made this problem so tough. Let's take a look. Find the coordinates of the point at which the particle is farthest to the left when time is greater than 0. Farthest to the left. So that is, we're going to be taking a look at dx dt, because that determines leftward and rightward movement, correct? We want to know when dx dt is the smallest it could be, right? What value of time makes dx dt the smallest number? Kind of the most negative number. Okay, so I'm only going to be taking a look at x prime here. So I'm going to go to my calculator. I'm going to turn off y2 and y3, leaving only my y1, my x prime. And they don't give me a maximum time, but they do tell me I'm greater than 0. So I'm going to start time at 0. And I'm going to go to, I don't know what I'm going to go to, maybe 10 will be sufficient, but we will see. Okay, and I have no idea what to make my y min and y max. I'm going to make it -5 to 5 and go from there. Let's see what that does. That gave me that. So that tells me that, remember, this is the graph of the x coordinate. So here the x coordinate is negative something. Okay. Here we get to 0. So this is just x prime. So when x prime is negative, the particle is moving to the left. When x prime is positive, the particle is moving to the right. That means that the furthest left is when x prime is whatever that is. So I'm going to go add a 0 in here, and then find where these two intersect. Second calc 5, enter, enter, enter. So it gave me at time 1. At time 1, the particle is farthest to the left. So I'm going to say that. Get my other pen out. The particle, and I need to say why. The particle moves to the left on 0 to 1, to time 1, since x prime of t is negative there. The particle moves, particle particle moves to the right after 1. So t is greater than 1. Since x prime of t is positive there. Okay, so the particle is farthest left at time 1. Okay, we want the coordinates of the point there. So I want x at 1 and x at time 1 and y at time 1. This is where I'm going to be using my initial conditions and the fundamental theorem of calculus. So x at time 1 minus x at time 0 is the integral 0 to 1 of x prime. Y at time 1 minus y at time 0 is the integral 0 to 1 of y prime. So x at time 1 is negative 2 plus integral 0 to 1 of x prime, and y at 1 will be 5 plus that integral, and I'm going to use my calculator to get both of those. Negative 2 plus math 9, 0 to 1 of y1, and 5 plus math 9, 0 to 1 of y2. So I've found the position of the particle at time 1 when it is farthest to the left. So I'm going to state my answer. The particle is farthest left at the point negative 2.603, 5.410. Okay, I've answered that question, but there is more here. Explain why there is no point at which the particle is farthest to the right. Okay, well, and the answer to that is that x prime graph. I only went to 10, but I'm guessing if I went to 100, it would never come down. It's never going to come down. So x prime is positive. I've already said that. X prime of t is greater than 0 when time is greater than 1. So the particle continues going to the right forever after time 1. The particle is never, I'm trying to use the wording that it says explain why there is no point at which the particle is farthest to the right. So the particle is never farthest from the right, to the right. Okay. I think I've answered everything. Let's see how they scored part C. For part C, they scored it as, it was worth 5 points. 1 point was for sets x prime of 0 equal to 0. I'm sorry, x prime of t equal to 0. Did I do that? Did I do that? I did when I compared x prime to 0. I did that. 1.4 explains leftmost at time 1, which we did, leftmost at time 1. 1 point for one coordinate of that leftmost point. And 1 point for the entire leftmost point position. The entire one. And then one last point for what we said at the very end, explanation for no rightmost point. So a big part was worth 5 points there. Okay, so what do you think? Could you have gotten any points on that? Could you have gotten more than 2 points on that? Alrighty. That's it for parametrics and vectors and motion along a curve.